Hello YouTube, this is Jessica from STEM APKs. Welcome to another tutorial. In this tutorial, we're going to continue where we left off in the last tutorial. So you remember in the last tutorial, we were working with images. We were able to send an image from the Raspberry Pi into our computer. And let's do it here again. Basically, what we're going to be doing is sending this image right here. I'll have it big because I'm going to be opening it, so I just want to show you. So this is the cockfight. Actually, that's not the one. That's why it's got an S. I added the S to make sure. Is this image right here? Is this image right there? So I'm going to be sending this image that you've seen it before, and I'm going to be sending it by using this file and src bin. And I'm going to be using this file, the sender that we saw before. And this is just a recap for people that did not watch my last video. So because I'm picking up where we left off. So now I'm going to be using this command, Pi basic image sender batch script is a batch, and then this image from this file into this my IP for my Mac using this port number. So if I hit enter, it comes in and there it is. And not only that, it's a pipe. So water keeps coming out. As long as the pipe is open, more and more images keep coming out and you keep doing it and doing it and doing it. This is the beauty of SOCAT, that it doesn't, it's very powerful, and it is very handy for certain applications. So let's stop. I can be here sending images all day. So let's not close the pipe, but just stop sending images. So in the last tutorial, we went over how to create the sender file, right? We 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 went over how to create the sender. In this tutorial, we need to talk about the listener, because in order to listen, like right now, as you can see here, I'm listening on port 2025. So you need a sender, which is the Raspberry Pi, or that could be any embedded system. It could be whatever is sending to me. So in that case, that is the server client, or if you want to call it. It's not really that, but whatever. Just to get the point across, it's going from the Pi to me. So me, I have to be able to receive it. So I'm just going to show you the code to receive it. So that's what we're going to do. Before we get into the code, remember there are some, that's why I have two different codes here. I have one that I call it Pi Basic Image Listener and Pi Basic Image Sender. They're specific to Linux, Debian, the stuff that the Raspberry Pi is using. Even though the Mac is a Unix, NIX base, or whatever you want to call it, I don't want to get into that. It's got certain similarities, but it's got some differences. So, for example, you might call this command in BSD, macOS, Linux this way, but in the Pi you might be calling it a different way. You might be calling same command like uh, change mod. There's some weird ones, and you're gonna see them. Be careful. That's all I'm saying, because you might get some errors because you think, well, they're both the same. No, they're not. One is BSD, one is GNU. So most of the time there is no problem, but sometimes there are some gotchas there, and that's why I'm bringing it up, because you're going to be seeing, I'm going to have on my GitHub, I'm going to have the Pi based stuff, and then the macOS specific stuff. Right now, this is macOS specific. Remember that. Just keep that in mind. I don't want you to get weird errors and you don't know what's going on. Okay, so this is the cleanup function that we need to do in order to kill any other previous SOCAT uh, process that is taking place, because right now I'm listening. But if I forget to close that port or something happened or whatever, A is a security issue, as you know, but also is not going to be able to use that port. So I have to kill it like three different ways to make sure that before I'm ready to receive. Okay, if not, I'm not going to receive on that port. So that's what's happening here. So basically, this here is it's handling interrupts, and in case you hit Control C or your Control Z, or you do some weird stuff, escape or something crazy, it handles that and through the trap cleanup, and so it makes sure that the function it gets used even though you did Control C, because you wanted to exit cleanly. Here we're creating this directory right there, receive images. That's what we're doing there, that directory. We're creating that directory, making sure that if it's not there, it's not going to throw an error saying that it's not there. Port 2025 is going to, again, ki kill anything that survived the first killing. So there is going to kill again. So this is what's happening there. Then it's going to verify that the port is open, that is actually free. This is a macOS specific command. That's why I put that there. So you remember this is one of those gotchas. And here is going to be using, basically what that is doing is it's going to forcefully kill any process using the port. It's going to list the process. Here it's going to list the process. It's going to print the process line by line using awk. And then here it's going to kill using kill -9 everything. So another time, there's a lot of killing going on. So here is going to check one more time that it's actually free. And there, if it's still, the port is still open, then you have two choices. You either use another port or you just reboot. So that's what we're doing here. And I had to do that because for some reason, some port, especially when you're using S-Quartz, because I'm using SSH to get into the Pi, sometimes weird stuff happens and doesn't get close. So it happened to me. So that's why I'm bringing it up. This is a while do, continuously will keep going until you close it. It will run indefinitely. This has been running for a long time. It will keep running until you close it. So that's what's happening there. This command, that's where all the magic happens right there. This whole tutorial is about SOCAT. It's using the socket, right, from TCP protocol. So what it's actually doing here is listening for all incoming TCP connections using the TCP protocol on port 2025. And you told it here that that's the port that you wanted to use. So that's what's happening there. Okay. Here is making sure that you're able to allow reuse of the address in case that you're waiting for the port to be closed or it's not fully closed after a previous connection. That's what that is. Here you're creating yourself a nice large buffer. So it's for efficiency issues, a better performance. I have 65 KB. And here we're opening creating a receive bin directory that is temporary. Remember, we're using the PPM as an intermediary between the compressed format, whether it's JPEG, PNG, or whatever compressed format you have, into PPM, and then back into the compressed format. This is what is being created here, and it's going to truncate before it writes, and here it will create it if it doesn't exist. In my case, it's right there, so it doesn't have to create it. It will wait one moment to make sure that this is completely written. Here is going to make sure that the file is not empty, that is empty or not empty or whatever you want to call it there in case whatever it is. And here's going to do a word count to make sure that it's not too small. It's not less than 8. And if it's not, it's going to complain. Here is going to get the file size. We did that in the last tutorial. This is the same thing. We're doing a word count to get the file size, and we're going to print the receive size. And now we need to extract the dimensions. We're going to get from the first 8 bytes. And here, this is one that I wanted to talk to you because it's going to read the 4 bytes from the offset 0. It's going to do it from for the width, and it's going to do for the height. Okay, so remember that here is going to get rid of any spaces. It's going to trim it, and it does it for the width. It's going to do it for the height, and then it's going to echo the dimensions. And it's going to give you the width and the height. And you're going to see it when I run it again. We're going to go over it, and you're going to see it. Here we just check that, make sure that they're not empty. The width is not empty. The height is not empty. And it's going to copy the receive bin, and it's going to give it a timestamp for the fail header that we can later use these for debugging. It's going to go into the receive bin, and it's nice to have because I was having some bug issues, so I had to do debugging. It was nice to put that in there. That's why I left it in there. I think it might be useful because you can see what's going on for debugging. He is going to try to convert to hex to the width and the height, width, height, and it's going to go from hex because you're going to go from hex to decimal. So it's going to be decimal. This is where the hex gets converted into decimal. And then it's going to do a last sanity check to make sure this conversion took place the way it should have. And if you see something that is funky, that is greater than 10,000, or the height is greater than 10,000, and the decimal is less than 0, or it's less, the height is less than 0, it's going to complain. This is the last sanity check before, hopefully, you get your timestamp. And then if everything goes well, it's going to give you the image with the real width decimal and the height decimal. And the timestamp is going to tell you what it was expecting, what is the actual size. And some of these, we did that in the last tutorial. It's going to skip the first 8 bytes. And if it's too small, if you remember, we would try to pad it with zeros. Let's say that I'm going to show you because it's I'll just show you in 1 minute because this is coming up. And it's going to convert the raw data to JPEG. Here it's doing all the conversion, all the timestamps. This is macOS specific. Verify that the file is not empty. And it's going to do another word count to make sure that the bytes. And like I said before, you can do all of these commands line by line, and they will work. You don't have to do the script, but it's nice and easy to just hit enter. And this is very important right here. Most significant bit is ending. And I'm going to show you uh, how the byte ordering sometimes can come and bite you in the butt if you're not careful. I'll just show you in 1 second. And it's done. So now let's send it through from the Raspberry Pi. So let's send it and let's talk about it. there's the image. We did that before. Let's close it. That's not what I want. This is what I want. So this is where it's getting the image dimensions. All of this is just stuff about the image. Here is giving you the dimensions. It's converting the image to PPM format. There it is. It's using PPM as an intermediary. It's extracting the raw RGB data for each pixel from PPM. We did that in the last two tutorials. It's taking that raw RGB data, and that's how many bytes there is. This is what it was expecting. So they match, so that's a good sign. Here it's going to start creating the header, and the header is going to be in hex. It's going to be 9001 and 000 and 1501 000. As you can see, this is from 0 to 8, right? And here is 9001. I think these are padded, and I think these are padded. I might be wrong. But if you enter this number, 9001 for the width, and if you enter that number, if you remember your hex, you don't have to be lazy like me. But if you don't, let's reset this. If we enter that number, 9001, and we get rid of that 0, and we convert, it gives you that number. And that number does not make very much sense. And you ask yourself, what's going on? And this is where that I talked to you about before, letter endian and LSB as opposed to MSB, most significant bit instead, or a least significant bit. So basically, it's not left to right how we're used to do numbering in the West. We gotta go 0190. And if we do that, now we get a number, the decimal, that it makes more sense. Same thing for the height. If we do 1501 and it's 400, so that's the width, 400. And then if we do, get rid of that 0, if we convert, it's going to give you something that doesn't make sense. Convert to LSB 15. Now it gives you a number. So it's 400 by 277. And if we look at the image, it's 400 by 277. So it's right. Here it will give you the header size. It's 8 bytes, 0 to 8, as you can see there. And it's going to give you the same bytes that we were dealing with. And once it gets the final raw image size, it's going to start the transmission, and it's going to do the port number on the IP address that you chose, and then it's going to attempt 3 times. If you remember, I have 3 ways to attempt to. You can do it 5, 10, whatever ways you want, and it's going to create it's going to take the stuff from the temporary file transmit bin that we did before. If you remember in the image sender py, now you're going to know why we spent some time talking about ppms, because this is all connected. These are the retries. You see the tries 1 of 3. This is where that is coming from. We did that in the last tutorial, and you see here where it says transmit bin. This is what the transmit bin that they're talking about, okay? And that's what is happening there. And then once it's doing that, it exits with status 0, nice and clean, transfer completed successfully. And then you get your image. And we got our image, and we're gonna do it again, just because I love this SOCAT. And there it is. And that's how you do it. So in the next tutorial, we're going to take this uh, batch stuff, and we're going to, because some of it is very efficient, and we're going to incorporate it with Rust and some cool stuff from Fulltick and create a nice graphical user interface that you're gonna love. But this is the end of this tutorial. If you like this tutorial, please click the like box, subscribe to my channel, and I will see you next time. Take care.